In this video, we'll be talking about how Elasticsearch organizes documents within indices, which is the plural for index. In this video, we'll look closely at how you create new indexes or indices, how we can use different naming patterns when we define what indices we use, a couple of different ways to set configurations for our new indexes. We'll delete indexes, we'll reindex indices, and then we'll look at some aliases. So the first thing we're going to look at is how do we create an index. This is where we store our documents. So the index contains different documents. Each document has its own attributes. This is where you'll store a day's worth of log files, or you'll store all of your cars that you're going to sell on your website. So this is the actual database that's a standalone Lucene index that you can set to store and look at your data. Let's look at the APIs that we can use to build a new index. So here we'll look at a create index API call. If you look at the API, we can use curl again like we've used before and we'll continue to use. It's an HTTP client. We'll execute an HTTP put method to our Elasticsearch server, which is running at localhost port 9200. And we're going to create an index called cars for sale. So this is what we've had before. I know I did stuff like curl, HTTP put. This is where we do cars for sale like we did before. And we're going to tell Elasticsearch that we're going to pass it some settings in a JSON format. So these settings, in this case, we're going to set the number of shards for this index to be 3. So this is a default number of different Lucene indexes that are used on our cluster to make this index. This is how we scale the data input and searching for our cluster, and specifically for this index. So imagine we have a 3-node cluster. So now we can have one shard, a primary shard on each node. So then when I search or when I index data, that load can be distributed across those 3 nodes. Now if I have a 5-node cluster and 3 shards, I'm not really taking advantage of the extra 2 nodes for this index. So that's always something that you want to be careful about and pay attention to. And then we can set the number of replicas. So this is how many replicas of each shard we want across our cluster. So this is basically the number of backups for each shard. This is how Elasticsearch is resilient in case of a crash, which rarely happens, but it does happen. So if a node goes down, you can have replicas of each of your shards, and your Elasticsearch cluster will take care of all those. So let's run this script to create our index within Elasticsearch. So now we've created this new index after we run our curl command that says, create the cars for sale index. Elasticsearch acknowledged it, and the shards were created. So let's talk about how we name our indices. So if you think about how we can store our data, we can keep things focused on the actual data. So we can make an index called cars, and we're going to create that in a minute, and then we're going to load a couple thousand or lots of thousands of car data. We can create an index called movies, or something called tweets. But if we're date focused like log files or events on a network that we're monitoring, we can use a date format to define the index name. So the example down here is 2018 January 1st or 0101/Apache logs, 2018 0102 Apache logs. So you'd see we'd make a rolling index every day. The comment I have here at the bottom talks about just because you have a date field doesn't really mean you need a daily or weekly or monthly index for your data. A date field just indicates the time an event happened. So in the case where we put cars for sale or we have movies and we want to keep track of when the movie was released, we don't necessarily have to have an index to represent every date that a movie could have been released. Because, you think back, movies have been coming out since, the early 1920s or something like that. We'd have bajillions of indices. So here, we're just going to create the indices for things we want rolling. So, like Apache logs, we want to keep, say, 15, 14 days of Apache logs. So we can have one from January 1st, January 2nd, January 3rd. And then when the date gets to be over 2 weeks, we can delete it. And we'll get into that in a second. So right now, let's look at how we can load some cars into our car index. So if we go back to our script, I'm going to do a little cheating because I know what's coming up. But let's look at a script called create indices. And here we're going to create a new index called cars. We're going to create another one called new cars, and you'll see why in a minute. And the important part here is I'm going to apply a settings file So you saw in the last script that we set the number of replicas and shards, and I'm not really worried about that right now. But what I want to show you here is I'm going to set up some mappings, specifically around a City 08, and there's some highway data. What we're looking at here is a data set from the EPA in the United States, where they release a list of vehicle and car efficiency, car miles per gallons. So we're just going to use that to kind of get a big general list of cars in our database. So what we'll do, we'll create those indices, setting those mappings. And now I have a little Python script here, and I'll show it to you quickly. It's a load vehicle script. What it does, I have this vehicles CSV file from the EPA. And for each line in that, it's a comma-separated values file, and it has information about a car, the make, the model, the year, and then it tells you information about fuel efficiency, and it's a gas guzzler, and anything like that. How many cylinders the engine has, displacement of the engine, that kind of stuff. So you can see we got up a lot of different data from integers, floats, strings. So that's all going to be in there. And you'll also see here, I'm using a add car function where I'm setting up the command row and I'm appending commands in the actual car. So I'm going to be using the bulk load interface, which we've talked about. And I'm going to be bulk loading in this cars index, which I have created using those mappings. So I know the data is going to be mapped how I want it to. And all this code will be available to you since you've purchased this course. So don't worry, you'll be able to analyze this a little bit more. Take your time when looking at it. So the idea here, I'm going to be loading 500 records at a time into Elasticsearch instead of one by one. So you'll see just how quickly it runs. All right, now that my cars are loaded, let's go into Kibana just to see what it looks like. So if we click on our monitoring tab, we can look at the indices we have available. We can see our cars index, and we can see we have 39.4 thousand, which is what I expected. So we can go and we can look at the discover, and I'll just show you an example of the data. So if we pick the index template, because I've already picked that, and here's the different things, the different data points from that file. We can look at the make, we can look at where's the model? We can look at the year. And here's what we're going to be looking at in a little bit. We're going to look at the highway, miles per gallon. And we're going to be looking at city miles per gallon. If I can find it. There it is. So let's see. Here's an example. In 1993, Subaru. Or did I not get the model? Where's my model? Let's find that again. So you can see I find on the left. I click add to get it in my table. This little Kibana feature, I can move it around. Let's see here. So we can come at it like this. We can say in 1993, Subaru Legacy all-wheel drive turbo got about 23 miles to the gallon highway and 17 miles to the gallon in the city. So that's the kind of data we have available. If you look at the actual structure, there's just a lot of data in here. And frankly, I don't know what half of it means. So we're going to be paying attention to some of it when we do some queries coming up. So now that we've inserted data into our index, we can quickly go back over the index configuration where we talked about the shards. Remember, it's how the data for that index is broken up into individual pieces, individual leucine indexes. This is how we scale. So you don't want to make too many shards because then you'll have some processing overhead every time you do a query, but you do want to have enough so you can scale across your cluster. I was reading on the Elasticsearch website that I think the maximum or the recommended size of a Elasticsearch shard is about 30 gigabytes. It's surprisingly large. Make sure you find out what the actual recommendation is, depending on the version of Elasticsearch you're using. I know they're coming out with new versions regularly, even as we are recording this video. And then the replicas are how often those shards are backed up, or how many backups of those shards there is. And this then leads to your cluster status. We're going to dig into this later, but we can look at the Kibana interface, and we can look at our Elasticsearch cluster, and here we can see their health is yellow. The only reason it's yellow is because I don't have enough nodes in the cluster yet to appropriately back up my shards. So you'll see that as we dig into another lesson of scaling our cluster. But for now, let's look at deleting these indices. So we've created an index previously called cars for sale. Like we said earlier, when we were naming indices, you can use that date-based naming structure where over time you can delete an index if it's more than 30 days old or 15 days old, depending on your use case or your business requirements or tech requirements. But I'll tell you, it's a really, really simple, probably dangerously simple API to delete an entire index. So you can delete gigabytes or your terabytes of data with one API call. So this is where authentication and authorization come in handy using XPack later. But for now, I can show you that it's pretty simple to just delete an index. So here, we'll look at this delete indices script that I wrote. And all it does, it calls curl, the HTTP delete method, localhost 9200 for Elasticsearch, and cars for sale. It's going to delete all the indexes, all the indices we just created. So let's run that and see what happens. That's how simple it is. So now we have no data in Elasticsearch. All right, let's reload that data, just because we need to. All right, now that our data is loading, let's say, oh no, we had a problem. We messed up our mappings, or our settings on our index are wrong and they're only available at creation time, not administration or runtime. What we need to do is re-index our data from one node to another. So we can say something like, okay, I had my cars node, and I'm going to use this HTTP post using this re-index command. And I'm going to tell Elasticsearch I need to re-index the cars index in a new index called new cars. So if we look at the create indices script we have, I cheated and I made the new cars index so I could get the mappings that I want. So then what I can do, I can look at the re-index script here that says curl post re-index from cars to new cars. So let's run that and see what happens. And pay attention to the timing here. You'll see that it's not instantaneous. Depending on the amount of data you have in your index, it could take longer or it could take shorter. This is going to take about 5 to 10 seconds. I see in that case it took 7 seconds. So what happened was we indexed 39,000 documents from cars to new cars. And the reason that's important is now we can apply a new mapping without having to go find our initial data source. We can just take the document that was in Elasticsearch and re-index it. In this case, the mapping is the same, so I didn't really do anything, but I think you can see the point. Well, now that we've made our re-index in this case, you'll notice that we changed the name of our index. So it was cars, and now we have new cars. Well, in a real production environment, you're probably going to have application clients or API clients that are actively searching against that car index. So what we now need to do is we need to make them think that cars exist still. So we have two choices. The first is we can re-index again from new cars back into cars and then delete new cars because it was kind of temporary. But imagine if that re-index took 34 hours. You can't really do that. So what we're going to do here is we're going to add an alias. So in this case, we're going to call this alias API, and we're going to say we're going to add an alias to the index new cars, and we're going to call it cars. So let's get to that in our script. So you'll see I have a script here called alias index, and the first line of it, and I'm going to run this by hand just to show you what I'm doing, is going to delete the cars index, because remember we have the new cars index. Okay, so now we've deleted cars, and just to show, I'm going to do a little search against cars, and it's going to fail. So you can see that, oh wow, what the heck happened there? You can see a lot of stuff that nothing happened. So then what we're going to do here is we're going to run this command to alias. So we can say alias, and now we have an alias. So now I can continue to query on the cars index as if it were there, even though it's not. All right, that was a long video talking about the indexes. So in our next video, we're going to start querying the data by hand. We're going to run a couple of different queries. I'm going to show you how we can get the data back that we've put in.